Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so we're talking about the product rule for exponents. What's product mean again? Yes. Okay, so when you multiply exponential expressions together, there's a rule. So let me grab another marker here. I just need an endless supply of markers, black markers. Okay, so there's going to be other rules, but let's put an expression on the board here. So let's say I've got like 3 to the 5th. What does that mean? Like if you didn't have a calculator, how would you do this problem?
3 times 3 times 3 times 3 times 3.
Right. So you're just multiplying 3 5 times. So you could do it like what I would do is I'd probably go, okay, what is that? 81. Because 9 times 9 is 81. 81 times 3 is 243. So you can break it up. But look at this. What's this expression? That's just 3 to the 3rd, right? And this is 3 squared. Right? 3 cubed times 3 squared. Well, that has to equal, since that there's 2 equal signs here. So this guy equals this guy. So what are you doing with those exponents to get this 5?
Just adding them.
Adding them. Isn't that weird? I thought this was a multiplication problem. So it's not like it's an addition problem. You're just counting how many total times that 3 is being multiplied. Okay, so this applies to exponents, or to variables as well, okay? So for example, x to the 5th times x to the 7th times x squared. What does this equal? X to the, yep. So x to the 14th, because that's just x, 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 XX. Don't say that too fast. It's awkward. Okay, so it's all you're doing. If you wanted to just multiply and just spell it out, you could do that. But you're just adding the exponents, right? Those are just x's. Now you can have different ones. So here's another example. X squared, y squared, x to the 5th, y cubed. Well, you can't add those exponents with x's and y's because those are 2 different numbers that you're multiplying, right? But you can combine those and combining isn't like combining like terms, right? You're just, how many x's are being multiplied? Well, there's 2 plus 5 is 7, and 2 plus 3 is 5. So far so good, does this make sense? Okay. Good. Now, here's the trick. Do this, all right? Tell me what this is. 3x squared plus 5x squared. What's the answer to that?
8x squared.
Okay, now, if I would have just given you this first before class began, you would have given me, thank you for answering that and being my example. You would have given me the right answer. You would have said 8x squared. Because when you combine like terms, you don't touch the x's, right? It's like 3 apples and 5 apples is 8 apples. It's not 8 apples, right? But since this was our context, this is going to be your challenge. This rule is easy, right? You just add the exponents. This rule is easy, right? When you add like terms, you just add the numbers in front of them. That's it. I mean, you're not touching those. But doing the 2 rules in the same problem or the same assignment is tricky, or on the same test. So the challenge is going back and forth. All right, what's the rule with multiplying exponential expressions? Okay, what's the rule with adding exponential expressions? Well, you can only add like terms. and then you don't even touch the exponents, right? Those are just the labels. So it's going to be a challenge to go back and forth, just like it's always been, multiplying and adding. Oh wait, all right, 3 plus 5 is 8, not 15. I just got done multiplying a bunch. So you used to struggle with that when you were younger, going back from addition and multiplication. It'll be a little bit of a struggle, but you'll get used to it, and you won't make this mistake too many times, but you might make it a few. Okay? So, let's try something else. So here's, I'm going to skip to example 3. Let's simplify this. X, y squared, x cubed. What is a simpler way to write this?
Just y 2x3.
Nope.
X, y to the third times x to the fourth.
Yes, because really, how many x's are being multiplied? There's 1 x here, and then there's 3 more x's. So how many total is that? Yes. So when you don't see an exponent, what exponent is it? 1. So you can put a 1 in there if it's easier. That will help your brain probably. Now you add the exponents. X to the 4th, y cubed, and you're done. Okay? Elkin, you're on fire today because you're like saying all the wrong answers I want you to say because you're helping the class. I mean, I don't know if you're doing it on purpose. Probably.
Get a free problem set.
You should for giving all the wrong answers. So, but this is the common mistake, is what Elkin just did. And so I'm so glad that he made that mistake so we could show you what not to do. I keep saying this and I feel like I'm digging myself in a bigger hole. Am I hurting your feelings? He's like, all right. So, let's see here. Let's do one more example. And then we're moving on to lesson 22. Okay, so now I want to simplify this expression. And when I say simplify, the general rule for simplifying is to write something with as least amount of ink or lead as possible. Okay, the first rule is to simplify each term separately. So if a term looked like this above it, then you could, there's an easier way, there's less ink or less lead I can write this with, right there. Okay? Down here in this term, can I write this simpler? X squared y p to the 5th, can I write that simpler? No. Good answer. No. If you're not answering, that's probably the right answer. Okay. And this I can't write simpler. This I can't write simpler. This I can't write simpler. So that's the general rule. But you're looking for like terms that you can combine. Are there any like terms? It looks like all of them are like terms, but they're not. There's only a couple there's only a couple different terms. So let me get my blue pen out. This one has x squared y p to the 5th. Anything else have x squared y p to the 5th? That has x, not x squared. That has y squared, not y. There's x squared y p to the 5th. Okay. And then this one has a y squared and just a normal x. That's what that looks like too. But it's difficult to see, isn't it? So this is where I want your inner OCD to kick in. If you don't have OCD, try to get some. All right? Hopefully my OCD will rub off on you, or Elkin's OCD will rub off on you. So,
Not OCD.
but you want to have it. I know it in your heart.
Yeah.
So, it's a superpower, but it's not like it's not a disorder. It's a superpower. Okay, so where are we at? So here's what might be helpful. Since multiplication is commutative, oh my gosh, I can't think of this word. It means it doesn't matter order what we do it in. So I like to alphabetize. If I've got a bunch of letters being multiplied, I like to alphabetize it. It doesn't matter, right? Because it's commutative. Oh my goodness. So I'm gonna rewrite it like this. P to the 5th x squared y plus, this one is 2p to the 5th xy squared. This one is 3p to the 5th x squared y, same thing, minus 7p to the 5th xy squared. So if you're confused at all, if you alphabetize each term, then now it's easy to see which ones are like terms. Oh, here's a p to the 5th x squared y. Oh, p to the 5th xy squared. Oh, that's a little different. Unless you're a little dyslexic or dyslexic, then those might look the same, right? So be careful. But I can see that these are the same, p to the 5th x squared y, p to the 5th x squared y, so combine those together. So how many total p to the 5th x squared y's do we have?
4.
Oh yeah, 4. Because there's 1 right there, right? 1 plus 3 is 4, and then how do I write it? Right, don't add the exponents because you're not multiplying. You only do that when you're multiplying exponential expressions. That's when you add the exponents. But this one, just leave it alone, p to the 5th x squared y. And then what am I left with my greens, my p to the 5th xy squareds? What's that? Not 9.
Oh.
-5. There you go. All right, so remember this is it's not like 3p to the 5th. See what's happening in my brain right now? It's breaking down. I'm losing it. 3p to the 5th x squared y minus something? No, it's minus 7p to the 5th xy squared. This is being subtracted from the group. Okay, so it needs to be subtracted from his own kind. All right. So what makes this easier, I think, is if you chicken scratch. Now you know that that's a -7 combined with a +2. So we end up with a -5p to the 5th xy squared.
Where did you get the 4 p to the 5th x2y?
Because these two are the same, right?
Yeah, but there's only 3.
There's 1 plus 3 is 4.
There's a 3 there. Well, I mean 1.
Because it's like saying you're sitting in a chair or you're sitting in one chair. Like, if there's no number in front of it, then there's just one of them. Okay, so like x. X plus 2x is 3x, right? It's a little bit more complicated because there's more variables, but this is just one chubby looking variable. One big fat variable, okay? So there's only one of them and there's 3 more over there. This is like a caramel decaf latte, so there's just more details to this variable term, but it still is a variable term. All right. You guys good on 21? Product rule. What do you do with the exponents? You add them. I read your lips. Okay, 22.
Black math, give me some math and I'll give you some flack. Black math.